Hello and welcome to a special lesson in our unit circle unit. This will appear right after our notes on evaluating trig functions, so make sure we have that set of notes before we actually fill this one in, if you don't already have them for whatever reason. And we're talking about even and odd functions. It's kind of a step back into Algebra 2, working with functions. How do you tell if a function is even or odd? And this is going to be useful for the unit circle when we're actually evaluating trig functions. So whether it's a t-value that's a negative pi over 3 or a positive pi over 3, it's going to be, you can easily evaluate it based off of if it's an even and odd, based off of if it's sine, cosine, or tangent, or what have you. So without further ado, function is even. So really quick, we'll start with the even functions. What that means is, well, it's not like a polynomial even, like a x squared, the highest power is squared, or to the 2, or x to the 4th. That is different than what we're talking about. It is not that. It's just talking about how it is symmetrical. So even functions. These are going to be symmetrical about the y-axis. So what that means is if I have, for instance, a graph, okay, just really quickly, our y-axis is goes up and down and will be symmetrical when we are navigating this. This is in pink, don't copy this down. So for instance, if you think of a quadratic that the vertex is on the y-axis, it is symmetrical on the left as it is the right. Every y output corresponds to the exact same value on the right. So if I have a negative 1 comma 2, it'd be 1 comma 2. So it's symmetrical in that regard. So that's what makes it even. Okay, so we could also have like absolute value. Absolute value is an even function because it is symmetrical across the y-axis. And like I mentioned, we also have quadratics. So if we have, for instance, let's try another one, a quadratic, it does not have to be at the origin. It could be anywhere just as long as it's symmetrical about the y-axis. It could be pointed down as well. It is symmetrical across the y-axis. Okay, so a little tidbit. It is even if x comma y is on the function or if fxy is on the function, then what you would do is you would take the negative x of it, and it would also the output would still be a positive y. In other words, if I plug in if I plug in a negative x into the original function, it will output the same output as if you were to do f of x. So this is what I mean. F of x, let's say it's like 1 comma negative 2. When I plug in the negative 1, because that's a negative x, right? Negative 1, you'll still get a negative 2. It will be the same y value across. Okay? So you'll have the opposite inputs. Here, better yet. You'll see it here better. These are opposite inputs, but you will still have same output. And that's how you could tell. If you have a table of values, that's how you'll be able to tell. Okay? Now we could easily do a quick problem like this. So a quick example. F of x is equal to x squared. If I plug in the opposite input, which would be negative x, we could see when we plug in the negative x squared, what is negative x squared? Well, it's going to be positive x squared. Because negative times a negative is a positive, and you can see the outputs are the same output. Different inputs, opposite inputs, same output. Okay. We could also, you could also just plug in numbers too. I'm going to do this in pink. If I said x was equal to 2, then we would get the output would be f of x would be 4. If f of negative 2, negative 2 squared, negative 2 times negative 2 is a positive 4, same output. Okay, so that's an even function. An odd function, odd functions. Are still are symmetrical, except it is not across the y-axis or the x-axis. These are symmetrical about the origin. And this one's a little trickier to see and understand. So, if for instance, we have a graph, quick example, two graphs, a linear function can be represented this way, except this one has to go through the origin. Okay? So, if I, for instance, have a graph like this, every input you get would be a positive x, positive y, right? Let's say 1, 1. On the opposite, if you're symmetrical about the origin, you're going to go negative x, or negative 1, negative 1. So you would have this version of it. Let's do this little mini side quest here. The odd functions. If you have x comma y on your on the function, then negative x, or the opposite input, would output the negative y, or opposite y. That's what makes this odd. In this case, opposite input, opposite output. So we would have f of negative x will output the negative version of the function. Oops, that's not supposed to be negative, that's supposed to be positive. So quick note, opposite inputs will produce opposite outputs. That's how you know it's odd, okay? We could also technically have a graph that is, let's say, cubic. If you want to do a really, really quick graph, or if you want to overlay it, you could. A graph that's kind of like this. This also works. Both of these are odd functions. Because if I have, for instance, 3, 4 here, this would be negative 3, negative 4. Okay? And then we could see that with a quick example. F of x, and this can be the red one. So let's do this. Let's do this in red to keep this organized. That is a cubic function. So we'll do x cubed. And let's say x is equal to 2. If I plug in 2, we will get 2 cubed, which is 8. But if I plug in a negative 2, then you get negative 2 cubed, which is equal to negative 8. So opposite inputs, you can see the 2 and the negative 2, opposite inputs, opposite outputs. Okay? So that's how you know if it's even or odd. And let's just do a couple quick examples. Yep, let's just do one for now. Is the function even or odd? Or neither? It could be neither. Even, odd, or neither. All right, so let's do f of x is equal to x to the fourth plus 6x squared. What we're going to do is we're going to plug in the opposite input, f of negative x. And when we plug it in, make sure you use parentheses, negative x to the fourth plus 6 times negative x squared. Okay? If the result of this is equal to x squared, or x squared, x to the fourth plus 6x squared, then we have even. If we get opposite inputs, then it will be odd, and then if it's neither, it's neither. So x to the fourth is still negative x to the fourth is still x to the fourth because we have four negative signs. Here we would have two negative signs. So we would have plus x squared, and then the 6 is still there. So f of negative x is still equal to the same output, okay? Which makes this even. And that's how you can check. We'll do more practice with this in class, but now we have a foundation what even and odd functions are. If you do have any questions, please ask them at the beginning of class, but we will definitely have more practice with this. And I'll see you. Bye.